friends. Welcome to the video lecture series of Tulsiramji Gaikwad Patil College of Engineering and Technology, NAC accredited A+ grade with a CGPA of 3.32. So, in the last lecture, we have started with the data structures and the basic definition of the data structure as well as abstract data types. Today, we are going to see how this various data types has been implemented. So, if I want to implement a data structure statically, I need to use a array. And if I want to use dynamically, or if I want to implement a data structure dynamically, I need to use a pointers. So let's discuss what this arrays means. So as you have seen, array is generally a collection of the same data types. Okay, or it is also considered as a collection of homogeneous data elements like integers. So if we are dealing with the syntax of the array, the syntax of the array is always written like this. First you have to mention a data types, then any variable names, and inside the rectangular bracket you have to specify the size of the array. Like here, integer array of 10. What does that 10 means? That array ARR is a variable which is the array which consists of the 10 elements. So this is how one can actually initialize the array in the C programming or the C++ program. So generally, whenever you are actually initializing your array, the 0 generally indicate that is the first element. And if I want to find out the size of the any array, it can be found out by this simple formula, that is the upper bound minus lower bound plus 1. So in case of the array of the 10, here the upper bound will be the 9 and lower bound will be the 0. So if you are doing 9 minus 0 plus 1, it is coming out to be 10. So this is how the size of the array can be calculated. And if you want to read or write through the loop, in case of the one-dimensional array, you can easily use the for loop to do that. Like this, for the reading the array, I have used here a for loop. It has initialized at I is equal to 0, I is less than or equal to 9, I plus plus, and to read it, I have a function scanf. So if you want to do the same experiment on the dev C, it can be done here. So first I have initialized this header file, and then I have written here integer I and integer ARR of 10. So I have applied a for loop over here, and I am using a scan for the reading the each elements in this program. So I am doing these compilations, and if I'm going to run this program, okay, here you need to initialize the various elements in your array like this. Like I'm using a 65, then 76, then 54, then 67, and then 78 and 98, and let's take a 100. Okay, so this is how you can initialize your array, or you can read the array. But for printing or writing the array, you have to use the function that is a printf. So I'm making some quite changes in here, and I'm using a printf function for the writing the array. Again, you have to go to the compile, and if you are going to run this program, okay, like if you are going to insert a 23, 34, 56 and so on, 78, 54 and 89, and I'm taking some arbitrary values inside it, and the 67 like this. Okay, one second, I need a little changes in this. I need to save it and compile again. Okay, and once you do it with this printf, let me check the things. So this is how you can read and write your array in the experiment. Okay. Next, so generally, what is the purpose to initialize the array? That is the first is the creation and the transversing. So these are the operations generally used in the data structure, like insertion, deletion, modification of the element, as well as the merging of the two different arrays. So there are the various data structures, that is of data types in the data structure. That is the first is considered as a list. So list is also a collection, but here it is collection of the variable numbers of the different data types. So the element in the list generally have the two fields, the one for the storing and the another for the storing the address of the next element. Like if we are going to use a graphical form, it will look like this. Can you see here? Here it is clearly mentioned the elements that AAA, which consists of actual information field, and there is also the pointer field. Pointer field generally deals with the address of the next element. That is the next element here. It is a BBB, and the second field of the BBB consists of the address of the CCC. Okay, so this is how the data has been considered under the list. And there are the various types of the linked list, that is the single linked list, doubly linked list, single circular linked list, and the doubly circular linked list. Don't worry about this terminology, we are going to learn more about it in the next module. There is another types of data, that is a stack. Stack is also considered, or it has a property of the LIFO, that is the last in first out. And stack is also defined as a collection of the elements like array, but it has a special features like a deletion and the insertion of the elements, and that can be done only from the one end, and it is considered the pointer from which we are going to insert our element, that is considered as a top. So it could be through of just like a stack of the plates placed on the table party, and guests always take off the fresh plate from the top, and the new plates are placed on the stack at the top. So this is how the stack abstract data type has been worked. It is also considered as a non-primitive data types, and when the element is inserted into the stack or removed from the stack, its base remains fixed where the top of the stack changes. So for the insertion of the elements, we have a special function, that is a push, or you can consider as an operation, and for the deletion of the element from the stack, it is called as a pop. So I have shown with the help of the diagram push and the pop over there. Now stack also can be implemented in the two ways. At the start of this lecture, I already told you when you have to do the static implementation, you are going to use the arrays. So that's why we have started with a basic concept of the arrays. Then if I want to implement a stack dynamically, I need to use the pointer. Then there is another abstract data type, that is called as a queue. Queue generally works on the principle of the FIFO, that is the first in first out. So here also there are the two pointers, that is the rear and the front, which is generally used to insert and the delete from the particular queue. Okay, so we can take a simple example of if you are going to compare the queue concept in terms of the real-time application, you can consider the people standing in the railway reservation. So those who are coming earlier will get a ticket first, like that. So this is a simple implementation of the queue using the array. Here you can see the two pointers, that is the front and the rear. So front generally gives you the first indexing in the queue, and the rear generally points out the last element in the queue. So again, it also has been implemented statically using the array, and the queue is implemented using the pointer in the dynamic implementation. Then there is another abstract data type, that is called as a tree. So it is generally a collection, or you can say it is a finite set of the data item. It is also comes under the non-linear type of the data structure, and in the tree you can see the hierarchical relationship between the various elements. Okay, so generally the topmost hierarchy is considered as a root of the tree, and remaining data atom which is under the tree are mutually a subset, exclusive subset of it. So tree always grow in the length towards the bottom in the data structure. Like we can take a simple graphical representation of the tree. Here you can clearly see A is considered as a root because is it at a higher hierarchy position. So tree organize the data into the branches which are related the information. Then there is another type, another abstract data types, that is a graph. Graph is a mathematical nonlinear data structure which is capable of the representing many kind of the physical structure. So it has found the application in the geography, chemistry and the engineering science. You can take a simple example of your Google map. In the Google map, if you want to travel from the one point to another point, you will find out there are the various way to reach that point. Okay, so here the point from the source to the destination is considered as a vertex, and the road which is connecting this source and the destination are considered as the edges of this graph. So simply in terms of the mathematical, it has been represented like a G of V comma E, where the V is considered as a vertices and the E is considered as the edges. So as edge connects a pair of the vertices, many have a weight such as length, cost and the another measuring instrument for according to the graph. And the vertices are shown as the point or the circle like this. Okay, so here you can clearly see there are the 5 vertices v1, v2, v3, v4, v5. There, if the weighted means if the some numerical element has been mentioned on the edges, that is called as a weighted graph. So here the first graph generally considered as a weighted graph, and also it points out from v1 to I need to travel to the v2, or I can also travel from the v3. Okay, so arrow has been mentioned very clearly, so that is also comes under the directed graph. Don't worry if you didn't get this, we will also see this under the graph models in details. So in the undirected or the unweighted graph, there is no numerical value mentioned on the edges, as well as there is no arrow is mentioned in this. So there are the various types of the graphs, directed graph, undirected, simple, weighted, connected and the non-connected graph. Again, I'm telling you, don't worry about this concept. It is just a basic, what you can say, basic criteria or the basic concept related to the graph. We will see in details in the graph model. Thank you.